All right, so permutations and combinations. This is all about a group of objects, and you are picking items from the group. Okay, so there's something where the order is important, and then something where the order does not matter. If it is a permutation, okay, it's a selection of a group of objects in which the order is important. The order is important. So we're going to talk about different situations where the order does matter. Okay, and that's something that you'll hear me say, is that order matters, or I'll say the order does not matter. So order matters for the permutation. Okay, and then you do have a formula. The formulas for permutation and combination are all going to be about n items, and that's the total number of items. Okay, they're taken r at a time, and our equation is n, and then you see the capital P, and then the r is given by the equation n factorial over n minus r factorial. I'm sorry, I know that's really small. Okay, so an example would be the number of permutations of 7 items taken 3 at a time is 7p3. So we would plug in the n value is 7. The r value is 3. So we have n factorial on top, 7 factorial, over n minus r. So 7 minus 3 factorial. Okay, so this would be 7 factorial over 4 factorial. Okay, and then, again, when you're doing this, think about, oh, it's 7 times 6 times 5 times 4 factorial. That way you can cancel out, the 4 factorials. Okay, and then you could just do 7 times 6 times 5. A quick way to do that would be, what's 7 times 5? Or, sorry, 6 times 5? 30. So 30 times 7 is 210. Okay, and then the other type, the combination, this is where the order does not matter. So if it's a combination, it's a grouping of items in which the order does not matter. Okay, so if you have n items taken r at a time, you can do NCR, and you have the n factorial over r factorial times n minus r factorial. And then, what do you guys think? Do you guys just think about, is this number going to be bigger or smaller than this? So let's write out our equation. We have 7 factorial over r factorial, which is 3. And then n minus r, so 7 minus 3 factorial. So using something very similar to last time, you have the 7 times 6 times 5 times 4 factorial over 3 factorial times 4 factorial. So these cancel. What are you guys thinking? Is this going to be larger or smaller? So we know the 7 times 6 times 5 is what? That's 210. That's what we had last time, right? But then we're taking that number and dividing it by 3 factorial. Yep, which is 6. So if you're taking this number and dividing it by something, is it going to be bigger or smaller? Smaller. options. So in the next question, I'm asking you to compare them. Are there always going to be more options with permutations? And that means when you have the same when the n and r values are the same. If you have the same total number and you're choosing the same number. What do you think? Is it always going to be like that? And if yes, then why? If no, why not? So let's look at the equations. What's the only thing different in the equations? So here you have n factorial over n minus r factorial. Here you have n factorial over r factorial times n minus r. So what's the only difference?
The denominator gets multiplied by r factorial.
Yeah, so your denominator has something extra in it. And if it's in the denominator, you're going to be dividing by that extra number. So anytime you divide by something bigger, is it getting smaller or is it getting larger? It's always going to get smaller because you're always going to be dividing by something extra, okay, by that r factorial. Okay, so yeah, it is always going to have more options for the permutation. Okay, and that's because the combination is divided by r factorial, making it smaller. And then also think about if the order matters. Right, and then if the order matters, you're always going to have more choices. Okay, so if the order that of what you have matters, you're going to have more options total. Okay, because if you're picking burger toppings, okay, you just tell the waiter what your toppings are. Oh, is that from last week? Yeah, you need that. Yes. If you're choosing burger toppings, right, like lettuce, tomato, cheese, you don't tell them what order you want it in, right? You just bring out the lettuce, the tomato, the cheese on it, okay? But if you did, then you could have many different combinations. You could have the cheese on top, which I would not recommend, then the tomato, then the lettuce, or you could have the tomato on top, then the cheese, then the lettuce. So there would be more options if the order of them mattered. So we're gonna look at some different options to see when order is gonna matter and when it won't. So you have to decide if it's a combination or a permutation. And I'm also going to show you how to do those on your calculator. So the first one says, how many ways can a student government select a president, vice president, secretary, and a treasurer from a group of 6 people? Okay, so whatever your total value is, if you have 6 people, the total number of people, that's your n value. Now, the amount that you're choosing, that is your r. So how many different positions are there? 4. So that's going to be your r. So from the group of 6, you're choosing 4 people. Now, does the order matter when you're choosing them? So let's think about it. You have president, vice president, secretary, and treasurer. So if you're putting them in positions, is it going to matter? If you wanted to be treasurer and then they put you in as president, would that matter? Yeah. If it's a position, it's going to matter, because if I choose, a group of people, right? I could have president, vice president, secretary, or I could have secretary, president, vice president, right? So there's different combinations, so the order does matter. And the order is always going to matter when you're assigning roles. Okay, so when you are assigning roles, this will always matter. So the order is important. Is that a permutation or a combination? Permutation. So we're going to do 6P4. That's your NPR. I'm going to show you how to do that on your calculator. You ready? All right, so we're going to put the 6 in first, and then we're going to go back to math, go over to probability. We're going to do 6P4, and then there are 360 combinations. Okay, so when you're doing your homework, really these are the two things I want to see: the 6P4 and then the total amount. Okay, so what did you plug in? What did you get out? All right, so for B, there are 12 different colored cubes in a bag. How many ways can Randall draw a set of 4 cubes from the bag? Okay, so the total, again, is the N. So in this case, it's 12. He's drawing 4 cubes. Okay, R equals 4. Okay, and then the set, it's a group of 4, so there's no sequence. Okay, if there's no sequential order, then it will be a permutation or combination. Yeah? So we're going to do 12C4. Okay, so go ahead and calculate that. And then I want you to start part C as well. Okay, so do your calculation. It's always that. You look at your question. Oh, yeah, they might. Yes, they might. So for the N, you're always looking for the total. Okay, so the 12C4, what do we get? Yeah, 495. All right, so the next one, I asked you to think about how many ways can a stylist arrange 5 of 8 vases left to right in a store display. So what are you guys thinking? Is order going to matter for this one? Yes, because they're being arranged from left to right. Okay, so if there's a sequential arrangement, right, she could have the purple vase, and then the blue, and then the green. Or start with the green. Okay, so it's 5 of 8 vases. So the N is the total. So the total is 8. They're choosing 5 of them. And then the order matters. That would be a permutation. you guys can calculate that. And again, so the order matters for this one. And now another way that you could do this is very similar to how we did the passwords. So think about if you're arranging the vases from left to right, you have 5 different spots, right? 5 different ways you can arrange them. How many choices do you have in the first spot in your display? 8. Okay, then how many choices do you have for the second spot? 7, because now you've already used a vase in your display. And then, so the next one you would have 6 choices, and then 5, and then 4. Okay, so if you multiply these together, you're going to get the same thing as when you do 8P5. So let's check that. For 8P5, what did you get? What did you get? Thanks for fake grabbing the calculators. All right, and then let's do the 8 times 7 times 6. And you guys just trust me. Believe me. Yay, same thing. Okay, so it doesn't matter which way you do this, okay? Either one of those are fine. Sometimes my brain actually works more like this, so I like doing this setup too. All right, here are the burger toppings. So Randy, you can choose 3 of the following toppings for his burger. Bacon, tomatoes, lettuce, onions, and mushrooms. How many burger options are there? Okay, so you're choosing 3, and then how many total options are there? Yeah, so there's 5 choices. We're going to assume Randy likes all these things. Okay, so your N is 5, your R is 3. Okay, and then is the order going to matter? Remember, did you tell the waiter the order that you want them to put the toppings on your burger? Most of us do not. Yeah, exactly. But now do you guys kind of want to? Excuse me, I need the bacon on top of the tomatoes and then the lettuce on that. And then you should get 10. Okay, so the order does not matter. All right, and then how many ways can you choose a 4-digit password if no digits can be repeated? So this is another one where there are multiple ways that you can do this. If you're choosing the 4 different password, okay, the 4 digits are going to be what you're choosing. So that is the R value. Anytime it is a password, does your order matter? So think about it. If my password is 12345, and I type in 54321, is it going to let me in? No, that's because the order matters. My password is password, and I type in WordPass. It will not let me get in. Okay? So if it's 4 digits, what's my total number? I'm choosing 4 of them. What's my total number? 10, because there's 10 digits. Yep. Okay, so you can do 10P4, or you can do it just like how we were doing it before. Remember when we just set up the spaces? If it's a 4-digit password, if they can't be repeated, it would be 10 times 9 times 8 times 7. So you choose which way you want to do that. And then what do we get? So practice typing it in. Cooper, were you here when I showed you how to do it? Okay, so maybe Luke can show you real quick. Oh, did you give me my calculator back? Here, come grab this. All right, and then, yeah, thanks. All right, so what did we get for this one? How many? the last one is Bree selecting 5 photos from a box of 25 to use in the yearbook. Okay, how many ways can she select 5 photos? Okay, so again, let's think of the total. Let's think of how many you're choosing. So the total is 25 photos. She's selecting 5 of them. What do you guys think? Does the order matter? So for this one, it just says she's picking 5 from the box. It doesn't say anything about the layout of the photos, so the order is not going to matter. If it said how many ways can she arrange the photos, from left to right, from top to bottom, then it would matter. If you're just choosing 5 out of the bunch, then it's not going to matter. So think about this when you're going to choose your, you guys will probably do your, well, I guess some of you will do senior pictures this one. And when you're setting up for your open house, you got to pick how many combinations are there. You're choosing 5 out of 25. How many different ways can we choose 5 photos? Yeah, what'd you get? Yes, that is a lot of ways, don't you think? Well, it depends. Usually we have seniors. But if you teach younger grades, a lot of times they won't come back. You get for them. Okay, so let's do, I gave you guys a 7.4. So like I said, these sections are short, so we're gonna do part of 7.4 today, and then we'll finish it tomorrow. So I chose 7.4 because it was also short.
I need 2, so I'm getting one for Ashley.
Oh, you are? Deshaun's not? Oh, okay. All right, so your two-way tables are what we're going to talk about next. And there is some heavy vocab in here, but it's not something that you're going to have to worry about. We'll go over it, okay? We're going to do two-way tables.